Trigonometry, lesson 1. So we're going to be learning a lot about the definitions, different angles, and how to get those angles. So let's just start with the base angle in standard position. Okay, so we're going to be looking at rotation angles in standard position, and basically what standard position means is you have a vertex, which is at the origin, you have an initial arm, which is along the x-axis, and you have an angle between 0 and 360 degrees. Okay, so if we're setting up a rotation angle, here's our vertex, here's our initial arm. The angle that rotates through is called our rotation angle, and it will terminate on a terminal arm here. Okay, so let's just label this as our rotation angle. It's always going to be from the initial arm to the terminal arm. And if you wanted, you could label that 0 degrees. So we always start with 0 degrees. Okay, if we're looking at a set of axes, there's 4 quadrants, and depending on how you rotate through those quadrants, will tell you if you have a positive angle or a negative angle. So just quickly, here we have 0 degrees, 90 degrees, 180, and 270. It's increasing by 90 degrees for each right angle. If we are rotating counterclockwise, you will result in a positive angle. Okay? But if we're starting at 0 and we rotate clockwise, you will result in a negative angle. So for example here, they're showing us negative 247. If I just relabel this, going from 0 to negative 90, to negative 180, to negative 270, to negative 360 degrees. Okay, let's rotate through. So 0 to 90 to 180, and negative 247 will be between negative 180 and negative 270. It's closer to negative 270, so you can see this terminal arm terminates closer to the negative 270 degrees. Okay, so clockwise we're moving negative, and counterclockwise results in a positive angle. So in the next examples, we have to sketch the rotation angle in standard position, and we're going to state the quadrants in which it terminates. So just a reminder, and if you want, you can just write this on the side. So quadrants go 1, 2, 3, 4. So sketching the rotation angle in standard position, and then stating the quadrant in which the angle terminates. Okay, so we're going 0, 90, 180, 270, it'll be just a little bit over at 290 degrees. Okay, so this right here is your rotation angle to the terminal arm. You got 290 degrees. What quadrant did it terminate in? 4. Thought I saw 3 fingers for a second, but it's in quadrant 4. Alright, the next one is a negative angle. So which direction will I move? Clockwise or counterclockwise? Clockwise, good. Okay, if you want, you can relabel your axes, negative 90, negative 180, negative 270. Okay, and we can start here. Okay, we're going 0, 90, and about there, 135. So negative 135 degrees. And we're terminating in quadrant 3. Okay, and lastly we're going to sketch 750 degrees. So you're saying in quadrant 1, how did you get that?
If it's 360 times 371, so you have 30 degrees left.
That's awesome. Okay, so let's just look at this. 1 rotation, 360 degrees. 2 rotations, 720 degrees, which means I need 30 degrees more. There's my terminal arm, and this spiral is my rotation angle, 750 degrees, and we result in quadrant 1. Awesome. in the next example, we're given ordered pairs, and we need to draw a rotation angle that terminates at that point. Okay, so the point A lies on the terminal arm of a rotation angle. In each case, we need to draw that angle in standard position. Okay, so let's draw a set of axes. And which quadrant would -3, 4 be in? 2. Good. So we're going to go over 1, 2, 3, and up 1, 2, 3, 4. There's our point. We need to draw a terminal arm to that point from the origin. And our rotation angle will start at 0 degrees and go to that point. Okay, that's our rotation angle. And it's in standard position because it's between 0 and 360. Okay, and it's also in standard position because we're coming from our initial arm is on the x-axis and our vertex is at the origin. Okay, -7, -2, what quadrant? 3. So we're going to go down 1, 2, 3, 4, 5, 6, 7, and down 1, 2. There's our point at -7, -2. Okay, draw your terminal arm connecting the point to the origin, and your rotation angle starts at 0 degrees to that point. Okay, next up we're going to look at coterminal angles. Coterminal angles are basically angles that terminate at the same point. So let's look at the first example here. We have 150 degrees. That will go to about here. Okay, so 0, 90, and 30 degrees shy of 180 degrees. Okay, next one, -210. So we have -90 degrees, -180 degrees. So let's go from 0, -90, -180, and there we have -210. Okay, 510 degrees. Okay, we're going to go around full circle. And how much more do I have to go? How do I figure that out?
360 minus 510 minus 360.
And what do you get?
150.
150. Good. Okay, so we've gone full circle, 360 degrees, and we need to go 150 degrees further. What do you guys notice? I mean, if my drawings were completely accurate, what do you guys notice about the terminal arm?
They all are in the same spot.
Good, they're all in the same location. Okay, so the principal angle of a set of coterminal angles is the smallest positive rotation angle with the same terminal arm. And just note that the principal angle is always an angle between 0 and 360 degrees. So if you were to look at the diagrams above, they all have the same terminal arm, but which would be the principal angle? The smallest positive rotation angle, right? You got it, 150. So there are infinitely many angles that are coterminal, and the reason for that is because of the rotations. Let's just take a look here. This last one was 360 degrees plus 150. Okay, what is this rotation angle in comparison to that rotation angle? It's an extra what?
360.
360. Okay, what about this one? If I was at 150 and I subtracted 360, what would I get? -210. So basically, coterminal angles are found by rotating around once, or twice, or 3 times, or 4 times. It doesn't matter how many times you rotate 360 degrees. And it doesn't matter if you rotate in the positive direction or the negative direction. Okay, as long as you're rotating by 360 degrees, you will always get back to that starting point. Okay, I can do a visual. If I spin in a circle, no matter how many times I spin around, I will end up back here. I don't think I could do 2 in a row without my feet on the ground, but maybe you guys could. Okay, so the general rule is you're going to take your principal angle. In this case, it's 150, and you would add 360 degrees times the number of rotations. So principal angle plus 360 degrees times the number of rotations. So in this example, we'd have 150 degrees plus 360 degrees times n rotations. Okay, just keep in mind n is an integer. You're not going to rotate by 3.5 times because you're not going to get it the same point. It has to be 1 full rotation or 2 full rotations, 3 full rotations. So let's just take a look at a few examples. We have 285 degrees, negative 13 degrees, and 395 degrees. We need to find the coterminal angles for these. So part 1, determine the angles, theta, where domain is between negative 360 degrees and positive 360 degrees, which is coterminal with the given angle. So we're going to try and figure out how many coterminal angles can we have with 285 degrees within this domain. Okay, between negative 360 and positive 360. So let's just draw it. Okay, 285, it's a positive angle, so we're rotating counterclockwise. 90, 180, 270, we're about here. Boom. How am I going to get back to that angle? Go back the other way?
Yeah.
Why couldn't I just add 360? Awesome. Okay, sure. To find a coterminal angle, I could add another rotation in the counterclockwise direction, but my answer would be bigger than 360, okay? Because 285 plus 360 is bigger than 360. So, like Chris was saying, we've got to go backwards. We're at 285, we've got to reverse it a full rotation. Okay, in other words, we're going 285 degrees minus 360 degrees. If you guys could help me out, what do you get? Positive or negative? Negative, good. Negative 75 degrees. Awesome. So that's a coterminal angle. Now part 2, write an expression involving the principal angle that represents all angles in the domain that are coterminal with the given angle. So in other words, we're taking 285 degrees, that's your principal angle, and you're going to add a full rotation times number of rotations. That would be the general rule for finding coterminal angles. Okay, now specifically in this domain, we can only find one, negative 75 degrees. That's the only other angle that would fall on the same terminal arm within that domain. Okay, I want you guys to try negative 13 degrees. Okay, so draw it out. And figure out what would be some coterminal angles.
So for that, it'd be plus 360 instead of minus 360?
So if I were to relate this to that question, what did we sub in for n? Negative 1. So it'd be like subtracting 360. Okay, but if we're looking at the general equation, we can just put n as an unknown number of times we rotate, whether it's in the positive or negative direction. Okay. So here we have negative 13 degrees. Need to figure out the coterminal angle. Okay, if you subtract 360, will you be outside the domain? Oh, what about if you add it? You'll be okay? So we're at negative 13 if I add 360. Okay, let's just do that. Negative 13 degrees plus 360 degrees. What do we get? 347. Okay, good. So that would be our coterminal angle. Now what would be a general rule? Would I use the negative 13 degrees or the 347?
347.
Why? Good, you need to use the principal angle. It's stating that right here. So that's the value between 0 and 360. So the general rule would be 347 degrees plus 360 degrees times a certain number of rotations. Keeping in mind n is only integers. Okay? Okay, last one here, 395. So we're going to go around one time plus a little bit more. So 395. So what could be a coterminal angle? 35? Good. How'd you get it?
Subtract by 360.
So you went 395 less 360. You got 35 degrees. Good. So if you think about it, full rotation is 360, and then you got to add 35 to get the 395. Okay, so there's one. Any others?
Yeah.
What?
Negative 325.
So then the second one was rotating in the negative direction twice.
Yeah.
And what did you get?
Negative 325.
Very good. Okay, so we actually have two coterminal angles here. By rotating in the negative direction. So we're going backwards one rotation, that gave us 35 degrees. Okay, and then if we go one more time, that puts us at negative 325 degrees. Okay, so what's your principal angle? What's between 0 and 395? 35. So the rule will be 35 degrees plus 360 degrees times n rotations to find your coterminal angles. So just remember, like, think about the term coexist. What does that mean? Together, or co-founders. It's kind of like two people and finding the same thing. With coterminal, it's two angles that share the same terminal arm. Okay, so they're co-angles that share the same terminal arm. Reference angles. These are the angles that exist between the x-axis and the terminal arm. And it's really common, I see people make the mistake of stating their reference angle between the y-axis, but if you can remember that it's always from the initial arm on the x-axis and the terminal arm, you'll be in good shape. So here they're showing us that we have, or telling us we have a rotation of 120, so that's to this terminal arm here. The reference angle will be between the x-axis and the terminal arm. We've got to figure out what is this angle right here. 60. How'd you get it though?
180 minus 120.
Perfect. Okay, so you're going to take the angle to the x-axis, which is 180 degrees, and you're going to subtract the rotation angle, which was 120 degrees. And from there we get our question mark, which is the reference angle of 60 degrees. Okay, so if you want, just label in here 60 degrees. That's your reference angle. And if you want to be thorough, you can label this your rotation angle. So whenever you're finding your reference angle, there's some key values that will help you find this. Okay, one value is 180 degrees. We subtracted the 180 degrees minus our rotation angle to get our reference angle. The other key values will be on the x-axis as well, either 0 degrees or 360 degrees. We ignore the 90 and the 270 for reference angles. Let's just do a little bit of practice. So we have an angle 243 degrees. We need to find the reference angle of this given angle. Okay, so let's draw 243 degrees. Oh, a little bit too far. There we go. Something like that. Okay, 243 degrees. Who can tell me where my reference angle will be? Is it this? Why not? Not between the x-axis. Don't make that mistake, please. Okay, it's right here. It's between the x-axis and the terminal arm. So we're trying to find this little angle here. Okay, and you're asking what mistake? Never between the y-axis and the terminal arm, never ever. It's always between the x-axis and the terminal arm. Okay. How are we going to figure this one out?
243 minus 1.
You got it. Okay, in this case it's our rotation angle minus 180 degrees. So what is 243 minus 180? 63 degrees. That's your reference angle. Okay, next one, 337 degrees. Let's draw this out. Up there. Where's your reference angle between? Good, between the x-axis and the terminal arm, so right here. So what's our calculation going to be? Pardon?
23.
Okay, how'd you get it though?
360 minus 237.
Good, so you take the angle on the x-axis, 360, you're going to subtract 337, and we get 23 degrees. Good, that's your reference angle. Okay, so just to summarize here, in quadrant 2 we went 180 minus rotation angle. Quadrant 3 we go rotation angle minus 180. Quadrant 4, 360 minus rotation angle. And what's going to happen in quadrant 1? Okay, if our rotation angle is 70 degrees, what's your reference? 70 degrees. So reference angle equals rotation angle. So it's the angle between the x-axis and the terminal arm.
Oh, so that is the reference.
Yeah, so the solution is 70 degrees. Quadrant 1's easy. So below is pretty much a summary, but they're telling you how to find the rotation angle if you're given the reference angle. So we're going to go through the rules. But we're also going to summarize if you're asked for the reference angle and given the rotation angle. Let's just review what we know. If you're given a rotation angle in quadrant 1, what will be the reference angle?
Rotation.
It's equal. Good. Okay, so the rotation angle is equal to the reference angle. So if you want, you can label this rotation angle too. Now, in the box in quadrant 2, they're telling us that if we're trying to solve for the rotation angle, we just need to go 180 degrees minus this reference angle, which would give us the rotation angle. Okay, what we did above though is if we're finding our reference angle, that would be equal to 180 minus our rotation angle. Okay, so the rules are the same, just we're switching out reference angle and rotation angle. Okay, so it's always 180 minus either rotation or reference. You'll always get one or the other. Okay, quadrant 3, for trying to find our rotation angle, we would go 180 degrees plus the reference angle. But what if we're trying to find our reference angle? Okay, what will that be equal to? It will be your rotation angle minus the 180, and that will leave you with the reference angle. Okay, so rotation angle, subtract 180 degrees. That will give you your reference angle. So it's just a little bit different. Lastly, in quadrant 4, if you're asked to find your rotation angle, you would take the 360 degrees on the x-axis and you would subtract the reference angle. That would then give you your rotation angle. But if you're given the rotation angle and you're asked to find the reference angle, what's your calculation? (360 degrees minus the rotation angle. So let's just take a look at a few examples and we're going to state the reference angle. The 195 degrees will be about here. We're in quadrant 3, so if you have to skip back to the page before to look at the little tricks, you can. But just keep in mind this is 180 degrees, your rotation angle is 195. How are you going to find this a little bit here? Subtract 195 degrees minus 180 degrees, and you get a reference angle of 15 degrees. I'm just going to give you guys an opportunity to try B and try C. And I want you to split back, use the rules if you need, to try and figure out the reference angle for B and C. So let's just review a little bit. If I wanted this to be a principal angle, what coterminal angle would be principal for that? How would I do it? So add 360. You want to go full circle to get a coterminal angle. So if you did that, what would this little bit be? 102? Okay, negative 258 plus 360 is 102. Okay, so let's just pretend we didn't even have the negative 258. We had 102. How am I going to find this little bit here? Yeah, 180 minus 102, and you get 78 degrees. Now, did anyone do that differently to get 78 degrees? You just used the negatives?
Yeah.
Okay, so you had negative 258. And what was your calculation?
I did like negative 258 minus negative 180.
Okay, so negative 258 minus,
And negative 180.
So that-
I like added
so that means you got negative 78?
yeah, and I just like.
But then you
went
knew
through
it had to be
I
a
knew it had to be
positive? Okay, or you could have gone negative 180 degrees, because that would be here, right?
Oh, minus.
Minus negative 258, and you'd get your 78 degrees. So it's up to you if you want to make a principal angle first, then find your reference angle, or just use common sense with negatives.
Why isn't it negative 78?
Okay, that's a good question. Reference angles will always be positive angles. Okay, so it's just the difference between the x-axis and where the terminal arm is. It's always going to be given in a positive angle. So although we're starting with a negative angle and that moves clockwise, okay, the angle that's between this arm and this arm is 78 degrees. Okay, so just note that reference angles are always given in positive terms. Okay. Okay, lastly we have negative 810 degrees. So let's figure out what this is as a positive, like what the principal angle is. What would you have to add? 360 degrees times how many rotations?
2.
3?
2.
2?
That was a guess.
So 2 rotations would only be 720. We'd still have a negative. So let's try multiplying by 3. What do we get? So what's negative 810 plus 3 times 360? What? I'll just do it. Okay, so negative 810 plus 260 times 3, 270 degrees.
Wait, what?
Okay.
Oh, we're minusing. Oh, I thought you were asking what 360 times.
Oh, okay. Gotcha.
I didn't know. I still didn't know.
So we rotate to 270 degrees. Where's my reference angle? Okay. Does it matter which side I go from? Okay, it could be here or here, but I'm at 270 degrees, which means regardless whether I measure this side or this side, my reference angle is is equal to 90 degrees. Okay, so first find your principal angle, and typically that makes life a little easier to find your reference angle. Number 6, we've got to find 4 angles between 0 and 360 degrees which have the same reference angle as the rotation angle negative 128. Let's start with negative 128. Negative 90, there we go, probably about there. Probably overshot a little bit, but that's negative 128 degrees. How about we find the principal angle first? So we have to find a coterminal angle. What would I do? It's got to be positive. So what am I going to add? 360 degrees. What do we get?
232.
232? Okay, thank you. Okay, so let's draw this. 232 degrees. We're at 90, 180, there we go. Same terminal arm? Yeah. Okay, so let's start with our quadrant 3 answer. So if this is a rotation angle of 232 degrees, and we know that the x-axis here is 180 degrees, okay, between the x-axis and that terminal arm, I have to find this angle here. What will my calculation be? How'd you do it?
232 minus 180.
Awesome. Okay, 232 degrees minus 180 degrees. That gives me a reference angle of 52 degrees. So from here, I know my reference angle is equal to 52 degrees. So in quadrant 1, if my reference angle is 52 degrees, What's your rotation angle? 52 degrees. Let's do that. Okay, quadrant 2, if my reference angle is 52 degrees, how am I going to calculate my rotation angle? Good. 180 minus 52, what do we get? Pardon? 128. Okay. Quadrant 3, did we already do that one?
Yes.
Okay, we've already figured it out. Okay, we had 232 degrees. And quadrant 4, we've got to figure out if I have a reference angle of 52 degrees, how am I going to calculate the rotation?
360 minus 52.
Okay, so we got 308 degrees. So these are my 4 angles. 52 degrees, 128 degrees, 232 degrees, and 308.